My name is Eric Johnson. I'm a Senior Developer Advocate for Serverless at AWS. This video is the second of a series designed to help you build serverless applications using the AWS Serverless Application Model, also known as AWS SAM. In this video, I demonstrate creating a serverless application using the SAM init command. Before I get started, to run this and any other examples in this series, you will need to have the AWS SAM CLI installed. For installation instructions, go to s12d.com/install-SAM. Now, back to the AWS SAM CLI. The SAM init command initializes a serverless application with an AWS SAM template. This can be one of the AWS managed templates or a custom one maintained by you. The AWS managed templates provide a folder structure for your application and configures the Lambda functions with an event source such as an Amazon API gateway, an Amazon S3 bucket, or any number of other event sources available in AWS SAM. To get a closer look, I'll walk you through a couple of different examples of creating a serverless application. Using my terminal, I run the command SAM init. I am then presented with a choice between using the AWS Quick Start templates or a custom template. In this first example, I choose AWS Quick Start template. I'm then asked to choose the package type for the Lambda functions. I can select zip to have my artifacts saved as a zip file in an Amazon S3 bucket, or image to have them saved as a container image in an Amazon ECR repository in my account. I choose zip. I'm now presented with a list of available runtimes. This list represents natively supported runtimes available for Lambda functions. I choose Python 3.8. Next, I am asked to choose a name for my application. I'm going to name it Python-zip. Finally, I am asked to choose from a list of AWS Quick Start templates. This particular list is for the Python runtime. However, different runtimes can have other template examples. I choose the Hello World example. The AWS SAM CLI then generates my application and prints out a report including the next steps, which can be found in the runtime-specific README file. Taking a look at the resulting file structure, there is an events folder that contains a mock event for local development. There is a Hello World folder that contains the source code and requirements file for dependencies, and there is a test folder that contains unit tests. At the root of the project is the README file for instructions and the template.yaml file, which is the SAM template for this application. When opening the template file, I first see that this is a SAM template as indicated by the serverless transform found on line 2. In the resources section, the template declares a single AWS Lambda function that uses an Amazon API Gateway REST API as an event source. The code URI parameter on line 17 points to the Hello World folder as the source code for the Lambda function. In this next example, I create a serverless application using container images to package the Lambda functions. In my terminal, I type SAM init again and choose AWS Quick Start template. For packaging, this time I select image. I am then presented with a collection of base images for each supported runtime. I choose Python 3.8-base to again use Python for my application. I name the application Python container, and the AWS SAM CLI generates my application and prints out a report. I'm not given a list of template choices because image-based applications only offer the Hello World template at the time of this recording. Looking at the application structure, I can see that, like the zip example, I have an events directory, a test directory, and a Hello World directory that contains the Lambda artifacts. I also have a README file for instructions and the AWS SAM template file. I open the template and I can see a difference in how the Lambda function is declared. Instead of a code URI parameter pointing to the directory of the function code, I have a package type parameter that is set to image. Additionally, there is a metadata section that contains information AWS SAM uses to build the image. The Docker file is set to the name of the Docker file used to create the image. The context points to the root directory of the image, and the Docker tag parameter declares part of the image tag. Under the Hello World directory, I open the Docker file. This file provides a set of instructions for Docker to build the image for this Lambda function. In this case, it copies down the proper base image. Then it copies the app and requirements file to the Docker image. This is the code file and dependencies manifest, respectively. It then installs all dependencies to the Docker image and sets the command to be run when the Lambda function is invoked. For the previous examples, I used the AWS Quick Start templates to initialize my apps. However, now that I have been using AWS SAM for a while, I have a certain way I like my templates to be set up. For example, I have a simple web app starter template based on container images that have all the comments removed, updated dependencies, and uses the Amazon API Gateway HTTP API instead of a REST API. To create a new application with my starter template, I'm going to use the custom template location during the application initialization. Before I run SAM init, I'm going to create a directory for my application and then change to that directory. SAM will copy the files to this directory during the init process. Once again, I start the process with SAM init, but this time I choose a custom template location. AWS SAM now asks me the location of the template and expects one of several options: the root of a Git repository, a Mercurial repository, an HTTPS address to a zip file, or a path to a local zip file. In this instance, I use a GitHub repository. Once I have selected my custom template location, AWS SAM then copies the files to the new directory and exits the process. I can now see that the new application is in place. In opening the template.yaml, I can see that the comments are gone and the Lambda function now uses an HTTP API as an event source. Another advantage of custom templates is the ability to add existing templates to your existing project. An example of this is to add continuous integration and continuous deployment, or CI/CD, to your application. At the root of my current project, I can use SAM init again. Here I choose a custom template and use the GitHub repo for the AWS CI/CD example. I am asked for a project name and a GitHub repository type. Then AWS SAM copies the new files into place. Now, if I look at my application, I see pipeline instructions, a build spec for AWS code build, and a pipeline.yaml file to deploy the CI/CD. For more information on this project, take a look at s12d.com/CICD-vid. So far, we have covered AWS Quick Start templates, custom templates, and a little bit of application structure. I want to take a moment and demonstrate another option available in the SAM init process. For this example, I'm going to create a project for developing in Java. I start with the SAM init command and select AWS Quick Start templates with the zip packaging. I then choose the Java 8.al2 runtime. This runtime means I will be running Java 8 Corretto on Amazon Linux 2. At this point, I am presented with a new option that we haven't seen before. AWS SAM wants to know if I want to manage my dependencies with Maven or Gradle. Because AWS SAM integrates with either of these package managers, I can choose which I prefer. In this instance, I am choosing Maven and then completing the SAM init process as per usual. This has been an overview of the AWS SAM CLI SAM init command. In this session, I covered creating applications from AWS Quick Starts, zip and container packaging options, and custom templates. I also spent a little time in application architecture and how dependencies are managed. In the next session of this series, I'm covering the AWS SAM build command. I encourage you to watch. For more content like this, visit serverlessland.com. Until then, thank you for watching. Again, my name is Eric Johnson, and you can find me on Twitter at EDJGeek. Have a great day, and remember, serverless for everyone.